my name is Emily, and I am a program manager on the Azure SQL team, focusing on high availability for Azure SQL database.
And my name is Roberto Bustos. I'm also a program manager for GODR in the Azure SQL team, and I focus on disaster recovery.
And today we'll be talking about high availability and disaster recovery for Azure SQL database. So the agenda for today, we're first going to start off with just a high-level overview of what is Azure SQL database and what is high availability and disaster recovery. And then I'm going to go into more detail specific to high availability side of things for Azure SQL. And then I'm going to hand it over to Roberto, who's going to cover disaster recovery. And then we're going to finish with a summary and questions. So starting off with an overview, just want to give a high-level picture of what is Azure SQL. So this is how we provide SQL Server Engine capabilities within Azure. So we have a few different flavors of Azure SQL that exist, starting with SQL Server on Azure Virtual Machines, which is our IaaS offering, where basically this is just really good for when you need that operating system level control, because you have way more control. It's just a VM running SQL Server. And then another offering we have two different flavors of PaaS offerings. So one is Azure SQL Managed Instance, which is really good for modernizing existing SQL Server applications to the cloud. It's really good for, in a sense, lifting and shifting existing workloads to the cloud. And then we have Azure SQL Database, which is really good for cloud native applications. And this is where we provide a lot of different capabilities, such as provisioned workloads, serverless workloads, hyperscale if you have very large databases. And this third PaaS service, Azure SQL Database, this is what we're going to be focusing on today, is our high availability and disaster recovery options specific to Azure SQL Database. However, SQL VM and SQL Managed Instance are also great offerings that we also have, and we have good HADR capabilities for those as well. So a lot of times you'll hear the concept of HADR, which stands for high availability disaster recovery. But let's just do an overview of what is high availability versus what is disaster recovery. So for high availability, what you're really targeting is continued availability with resilience to more localized failures, whereas disaster recovery, that's really looking at having that business continuity in the case of a more widespread disaster and being able to quickly recover from a large disaster scenario. So with high availability, that's really within a region, so it's a more localized issue. And failover happens within the magnitude of seconds, so it's really being able to quickly recover and have your data back up and running. Whereas disaster recovery, this spans a larger scale of issues where your failover would actually happen across different Azure regions. And this would really target more of that large scale type of disruption than high availability, which focuses on an within region localized issue. And then, so for high availability, we really, for SQL DB, we target synchronous replication in this case. So that way you always have a replica that's fully caught up with your primary, and you have that, you just have that caught up data, which is there for your localized failover. And then for disaster recovery, we use asynchronous replication. Since this is targeting more across regions, you don't have to worry about having all of your, waiting for all of these commits to happen to a replica that's in another region. So that is more focusing on the performance aspect. So we use asynchronous replication for disaster recovery. And then in terms of SLA, for high availability, how we measure this in our SLA is something called uptime percentage, which that's the amount of nines that you typically see. So if you hear something like we have 4 nines, that is referring to uptime percentage, which is a high availability SLA. So the amount of time your database is up and running. Whereas for disaster recovery, the SLA metrics that are used are RPO, recovery point objective, and RTO, recovery time objective. Great. So now that we just went over a high-level overview of what's high availability versus what's disaster recovery, let's look at the different layers of HADR that we offer for Azure SQL Database. Starting with local redundancy, we provide local redundancy within the same data center. So this is one level that we offer where your data will be replicated in a more localized region. Then you can bring it to another layer, which would be zone redundancy, which I'll go into more detail on the high availability side of things. But this essentially means within your same Azure region, you will have redundancy between different physically separate data centers within that same Azure region. And then finally, the last layer of HADR is geo-redundancy, where you can replicate your data to an entirely different Azure region, which a lot of that focus is more in the disaster recovery side of things. So now that we've done an overview of Azure SQL and what is high availability and disaster recovery, let's look more into the high availability side of things. So for Azure SQL, we provide high availability capabilities built in whenever you provision an Azure SQL database. And this high availability is configured in different ways based on our different service tiers, which I'll go into more details on how this looks for the different service tiers. But at high level, we have 3 different service tiers. So we have the general purpose tier, which is really good for most of your business workloads. And this provides serverless capabilities as well as provisioned offerings. And then the configuration for this is essentially you have remote storage that your compute connects to. And then business critical, this is a service tier offering that we provide when you really need that low latency, fast recovery that would correspond with having local storage. And in this case, you also have a readable secondary that you can send read-only queries over to. And then finally, our other service tier that we'll go over is hyperscale, which this offering is really good for most of your business workloads where you need highly scalable storage and read scale requirements. And this really allows you to have very large amounts of data, exceeding, basically providing a limitless scale of data for your database. So these are the different tiers. I'm now going to go into more detail of each of these tiers specific to the local redundant configuration, which is the default configuration if you were to spin up a general purpose business critical or hyperscale database. So starting with the general purpose tier, what this architecture looks like. So you have your primary compute replica, which connects to remote storage, which uses locally redundant storage. So that's replicated within your same localized area within a data center within an Azure region. And then this also has backup files, which are by default configured to be geo-redundant. However, we provide capabilities for you to change this backup configuration to be zone redundant or local redundant. And then how failover happens is in the case that your database would need to failover because of some kind of issue, there would be nodes of spare capacity that your database can fail, your primary compute replica can fail over to within the same data center within your Azure region. So this is essentially how a general purpose database looks whenever you create one in Azure SQL database. You just have that remote storage connected to your compute replica. Then for business critical tier, how this differs from general purpose is you actually have 4 replicas total. You have your primary replica, and then it's connected to 3 additional secondary replicas based on always on availability groups, which you may be familiar with from SQL Server. It's the same concept, except this is configured out of the box for you whenever you create a business critical Azure SQL database. So you have these 4 total replicas connected through always on availability groups. And each of these replicas uses the local storage for any storage. So both the compute and storage are connected locally. And it's just the backups that we use remote storage for. And it's the same as with the general purpose tier, how by default this is global redundant backup storage. However, this can be configured to be zone redundant or local redundant if that's what you prefer. And so with these 4 replicas, what happens in the case of an issue that with your primary replica, you can fail over to a secondary replica since you already have these 4 created. Another capability of the business critical tier is since you have each of these replicas, one of the secondaries can actually be used to send read-only workloads for read scale out. So you can configure your business critical database to have read-write workloads sent to your primary and then read-only ones sent to the secondary as well. So not only does it provide that failover capability, but you also have read scale out capability out of the box with a business critical Azure SQL database. And then finally, we have Hyperscale as our other service offering. So there's 4 layers of a Hyperscale database, starting with compute. So with compute, the compute layer, you can create a primary compute replica and then multiple secondary compute replicas. You can configure to have a varying number of between 0 and 4 of these secondary replicas that can be used for failover. And these replicas, you also can send read-only workloads to one of the secondary replicas, similar to what we talked about with the business critical tier. And then for storage, how this works is we have a concept of page servers, where each of these page servers will read pages from the storage, which is stored in Azure Standard Storage, which that layer is already replicated. You have it's geo-replicated within Azure Standard Storage, and the page servers read pages, then send them to the compute nodes from the storage. And each of these page servers you have a replica for as well. So you have that high availability at each of these layers, in addition to any replicas you would create for your compute nodes. Then additionally, we have our log service, which it basically handles all the logs being sent to the page servers for reading your storage. So altogether, this is the architecture for hyperscale high availability, and we allow for that automatic failover in the case of an outage by failing over to one of your secondary compute replicas in a similar way as what we discussed with automatic failover for general purpose and business critical tiers. So now that's out of the box what our default configuration is across those 3 different tiers. Now let's look more into detail on how to get an even a further layer of high availability and disaster recovery by using availability zones. So as a starting point, let's go over what even is an availability zone. So an availability zone is a physically separate location within an Azure region. So each Azure region that has availability zones has at minimum 3 of these availability zones within the Azure region. And so each of these availability zones has independent power, cooling, and networking, with the idea that if something happens to one of the zones, the other zones within your Azure region should not be affected. And so how we really use this to provide additional resiliency is through replicating your data between the different availability zones within your Azure region. Because if something happens to one zone and your data is replicated to the other zones, since these zones are physically separate with different powering, cooling, and networking, they should not be affected in the case of a zone level outage in one of the zones. So this is all up what an availability zone looks like. Now let's look at how we utilize availability zones with Azure SQL Database. So starting with the business critical tier, we provide zone redundant configuration as an option for the business critical tier. And what this looks like if you were to enable the zone redundant configuration for your business critical Azure SQL Database. So you still have those 4 replicas that you have out of the box, similar to what you saw in the local redundant configuration we discussed earlier. However, these 4 replicas are now going to be automatically spread between the different availability zones. And so backup is still configured the same way as we discussed earlier, how that's in remote Azure Standard Storage, which can be configured to be local redundant, zone redundant, or geo redundant. But in terms of the actual compute replicas, what happens in the case of automatic failover, if there's an outage detected, Since you have replicas spread between the different availability zones, this allows that automatic protection in the case of a zone level failure, because you can just fail over to a secondary replica in another zone and your database will still be up and running. So specific to the business critical tier, this is offered at no additional cost, the zone redundant configuration. All you have to do is enable this configuration and your database will be configured with your secondaries in different zones, providing that zone level resiliency. Enabling this configuration is also the way that we provide that additional 99.995% SLA. So by default, the SLA across Azure SQL database for business critical tier is 99.99. And so enabling this configuration allows you to get that extra 0.005% SLA, which is a good additional uptime that we guarantee with this configuration. So now let's take a look at how fast this failover can happen. So now I'm going to be doing a simple demo in Azure Data Studio to show how quick these failovers are for a zone redundant business critical database. So as you'll see, if we get the information about the database that I'll be using, it is in fact a business critical database, and it has the zone redundant configuration enabled. And now what I'm going to do is run an ostress command, and this is just going to be a very basic select statement that I'm going to run over and over again on a table on this database. This database has AdventureWorks uploaded on it, so it's just going to be querying for the count from this table in AdventureWorks. And so what you'll see once I start running this ostress command against this database is that you'll start seeing 847 over and over again. And essentially what that is showing is that the select statement is succeeding, so we're able to successfully connect to the database. So as you keep seeing the 847s, what that means is that we're successfully connecting, the database is available, we're up and running. Now I'm going to invoke a failover on this zone redundant business critical database. And what you'll start seeing is that you no longer can connect to the database. However, these 847 will start occurring again once you're able to connect, which will only be in the order of a few seconds. And there you have it. After just a few seconds, after the failover, you're able to be up and running and connect to your database. So what this really showed is for your business critical zone redundant database, failover happens within the order of just a few seconds, and this failover happens between different availability zones. So a whole zone can go down and your database will be up and running in another availability zone in a matter of just a few seconds. Great, so now that we've gone over the zone redundant configuration for the business critical tier, let's take a look at the zone redundant configuration for general purpose and serverless tiers. This is currently in public preview, and it's only in a subset of regions which are provided here in this list for reference. Now what you're going to see is the architecture for this zone redundant configuration for general purpose and serverless databases looks very similar to what you saw for the locally redundant configuration. However, some key differences that will make this zone resilient in comparison to the local redundant configuration are that the remote storage uses something called ZRS, which is zone redundant storage. So what that means is that Azure storage, which is being used for the remote storage, will automatically replicate your data files across the different availability zones within your Azure region. So this synchronous replication of this data just automatically happens in remote storage. Backups are still configured the same way as we've discussed in the past. However, what we guarantee for the zone redundant configuration for general purpose and serverless tiers is we guarantee that there will be capacity for your database available in the other availability zones. So in the case that a whole availability zone goes down, you're guaranteed compute capacity in another availability zone within your same Azure region that can be used for failover for your primary compute replica. So you'll have that compute level zone resiliency as well as the zone resiliency with zone redundant storage for the remote storage. And the combination of these two, what that offers is that your database will be able to still be up and running in the case of a whole zone going down. One thing to note, so this preview for the zone redundant configuration of general purpose and serverless databases, this also comes at an additional cost, which more information about the pricing details related to the zone redundant configuration for general purpose tier can be found in our pricing pages, which are provided in the slides for reference. Great, so now let's take a look at a demo of how fast failover between zones happens for general purpose and serverless databases. So starting with provisioned general purpose database. If you look at this database, it is in fact general purpose, and it is enabled to be zone redundant. So this is going to be the same format as what we saw for the business critical database, where this database is AdventureWorks, and we're going to run the same ostress command, which is essentially just querying over and over again the same select statement. So as you see the 847, what that means is that we were able to successfully query this database. The database is available and we're successfully connecting to it. As I invoke failover, you'll see we're no longer connecting. We no longer see at 847, but this will only be in the matter of a few seconds, and then we're up and running yet again in a new availability zone. So now that we saw it for a provisioned general purpose database, let's see how this looks for a serverless database as well. So getting the information about the serverless database that has AdventureWorks on it, that we're using for this part of the demo. As you see, it is general purpose tier. However, it is serverless, which you can see by that S designation, and it's zone redundant because zone redundant is set to true. So for this serverless database, we're going to run the same ostress command. Where you'll see that 847, you're able to successfully connect. Now, when I invoke failover, you'll no longer be connecting, as you see right here. You no longer see 847. This will only be the matter of a few seconds. And then it's up and running, able to successfully connect again. As you can see, the 847s they're outputting. So what you saw in these demos is that in the case of an issue that happens in your availability zone that's hosting the primary replica for your zone redundant business critical, general purpose, or serverless database, something happens, they can fail over to another availability zone in the matter of just a few seconds, really providing that high level of availability, even in the case of a whole zone going down. Let's look at our overall SLAs across our different tiers. So we offer 99.99% uptime SLA across basic, standard, general purpose tiers, and then the premium and business critical tiers with local redundant configuration enabled. And then for hyperscale with 2 replicas, we also offer 99.99%, which is 4 nines of uptime, which we offer 3 nines with 1 replica and 99.5% with 0 replicas. And so what this essentially means is that is the percentage of time that your database, we say you'll be up and running. You'll be able to have all continuous login attempts be successful to the database within that time, within 99.99% of the time that you have the database within a month. So if you look at when you enable zone redundancy, so zone redundant configuration for your business critical tier, we actually offer an additional 0.005% uptime, which might not sound like a lot, but if you look at when you convert that into actual time, 99.99% uptime offers a maximum downtime of 52.56 minutes per year, whereas 4 nines and a 5, which is our zone redundant configuration for business critical tier uptime SLA, we offer 26.28 minutes per year of downtime. So the amount of downtime that you can have is halved by just enabling the zone redundant configuration. So you get all that additional uptime SLA at no additional cost for the zone redundant configuration for business critical Azure SQL database. So now that we've done this overview of high availability for Azure SQL database, I'm going to hand it over to Roberto to cover disaster recovery side of things.
Okay, so yeah, I'm gonna be talking now about disaster recovery. And how do we handle this in Azure? It's going to start with this. Okay, maybe we need to cut a little bit. Give me 1 second. Okay, so we're gonna start talking about disaster recovery, and so business continuity is a key requirement to implement any business critical system. Natural disasters like hurricanes, earthquakes, or even a man-made disaster like a war, could cause permanent damage or partial loss in an entire data center. So the recommendation is that every production database should be using Geo strategy. So today I'm gonna be showing how in Azure SQL we have this service that actually will help you to be prepared in a case of a disaster in the entire region. So first of all, I'm gonna show you how the architecture is, and we have here a very simple level architecture about GeoDR. And as you can see in the primary region, you have the database in the left and you have read and writes. In the moment we have a disaster or you want to do a plant failover, you can the traffic of the users is going to be changed to the secondary region, and in this secondary database is going to be having the read and writes. In this case scenario, we're going to have different endpoints. So you might need to update your application for this case. We're going to go in more details about the endpoints and how can we actually even have endpoints that don't change. So talking about more about geo-replication, it replicates using transaction logs. So this is not transactional replication that uses DML commands like insert, update, or delete. We just replicate the transaction logs. This is an asynchronous replication. On the primary before they are replicated to the secondary database. Now, there is a way you can force synchronization. Let's say you want to ensure you replicate critical changes from the primary and the secondary. So you want to make the replication synchronous. You can do that. We have a procedure called, the name of the procedure is SP-wait for database copy sync. So basically, when you use this procedure, you are forcing synchronization between the primary and the secondary. Now, this will impact the performance, of course, because it's blocking the calling thread until all committed transactions are replicated. So we recommend to use this only in cases where you want to ensure certain critical changes are put in the secondary. But if you use this in a permanent way, of course, the performance is going to be affected. We also have different ways you can interact with the geo-replication in Azure. One is the Azure portal. We have also PowerShell. You can do it through Transaction SQL or REST APIs. Now, for geo-replication, we also have up to 4 secondaries are supported in the same or in different regions. But we're going to see more details on that. How can we actually support more than 4? And we have this architecture that you can see here. And as you can see in your left, we have the primary and 4 secondaries. Now, each of memory, some compute in order to the replication. So this primary is using resources for 4 secondaries. Now, what happens if you want to reduce the resources that are being used for replication in the primary? Then you can do something called chaining. So in the case of chaining, for example, as you can see, you have the primary here, and the primary is actually only having one direct secondary, the number 1 database here. And then this number 1 database has at the same time 2 secondaries, number 2 and number 3 database. And at the same time, this number 2 database has another 2 secondaries. So basically, you can do in this way like an endless chain of secondaries. You had unlimited scale of databases replication, endless number of databases. Now, the advantage of the architecture in the right, the chaining, is that you reduce the overhead on the primary, because as you can see, the primary only has to use certain memory and compute to replicate to one database, compared to the left architecture that has to do it for 4 databases. The disadvantage of the chaining architecture, of course, is that you increase the lag. Like, for example, if you measure the lag between the primary and the last database in the chain, of course, the lag is going to be bigger because the data has to jump between several databases before getting the data into the last database. So these are one of the architectures you can use with GeoDR. Now, there is also, for example, we have here our primary. Let's say you deploy a primary in East US, that is Virginia, and then you deploy your secondary in South Central US, that is Texas, the green in green here. So of course, the most important use case is if you have a disaster in Virginia, in East US, you can actually fail over to your database in Texas, in South Central US. Now, there are also other use cases. For example, let's say you have customers or employees that need to do reporting in your databases, and these customers are located in Texas. So basically, with this, in this scenario, they can actually query the secondary database. So they will have low latency to run reports because the database is located in the same region where they are located, and you won't be affecting the performance of the primary with the reporting. In addition, active replication can be used, of course, for database migration. Let's say you want to migrate your database to a different region, and you require minimum downtime. You can do this with geo-replication. So in this case, let's say you want to migrate this from East US to South Central US. That's one use case. Another is, let's say you want to do application upgrades. You can create a secondary as a failback copy during the application upgrades. Now, we have 2 types of failover. We have the planned failover. So planned failover switches the roles of primary and secondary databases after full synchronization is completed. This is an online operation that does not result in data loss. So the time of the operation depends on the size of the transaction log on the primary that needs to be synchronized. And of course, planned failover, as we discussed, it covers is for scenarios where maybe you want to perform a disaster recovery drills in production. When data loss is not acceptable, you want to make sure that your actually DR solution is working, so you can perform drills. As we mentioned before, you can relocate database to a different region, or you can use this to return the database to the primary region after the outage has been mitigated, like let's say a failback scenario. So basically, in this case, you will do a planned failover. You don't lose any data because basically everything is synchronized before the failover is done. Now, the second option is the unplanned failover. The unplanned or forced failover immediately switches the secondary to the primary role without any synchronization with the primary. So basically, any transaction committed to the primary but not replicated to the secondary will be lost. And this operation, of course, is designated as a recovery method during outages. You don't have another option. There is a disaster, so this was not planned. Of course, you do this forced or unplanned failover, and there might be some small amount of data that could be lost. Like, for example, all unsynchronized transactions will not be synchronized. Now, once the disaster finishes, you might have a small number of transactions that were not synchronized in the new primary. So basically, what you have to do is just to manually merge this group of transactions. Azure won't do it won't do this for you because otherwise we can have some conflicts in the primary. But the main use case, of course, is the unplanned failover, because when a disaster happens, you want to make sure your secondary is there to take over the load and also to have the data available. Now, we cannot talk about geo-replication without talking about auto failover groups. So the auto failover groups feature allows you to manage the replication and failover of a group of databases. Failover group is an abstraction that runs on top of the existing active geo replication. So it's not a different solution, it's just running on top. You can actually failover a group of databases. Now, there are certain differences between and different use case for geo replication and auto failover groups. For example, as you can see in this table, we only support managed instance in auto failover groups. The reason is GeoDR is done at the database level. So in the case of managed instance, currently what we do is we take the entire instance with all the databases that are inside, and we actually replicate the entire instance to a different region. And this is only supported, of course, in failover groups. Now we have also something called automatic failover, also only supported in auto failover groups. And basically here you're letting Azure to manage the failover in a case of a failure. So the way it works is Azure triggers failover after a failure is detected and a grace period has expired. Now you can set this grace period. The minimum is 1 hour. And the reason is that it involves human action from our operations team. So when we have a failure, we try first to mitigate the outage in that grace period, in that hour. And if we cannot fix the problem, then we'll do the failover. So basically what you're telling us is when a disaster happens, in this first hour, we'll try to fix it, or we will just failover automatically the database. Of course, during this time, if you want to failover and you don't want to wait until that hour happens, then you can always, of course, do a manual failover through your application, or you can manually just failover the database at any time. Now, the type of failures that we are managing with auto failover groups are cluster-wide outages like power, network, cooling failure, fire, flood. We won't do a failover only if one database of the group is down. The reason is because we'll be affecting the rest of the databases in the group, as all of them use the same endpoint listener. So for these cases, when we have one database that is failing only in the group, we have built-in high availability capabilities in Azure that will address this issue. So that is why it's important that when you design your failover groups, you should have databases in the same group that you feel comfortable to failover together. Otherwise, if you don't want them to failover together, you can put them either one database per group, or you can use geo replication that basically is just at the database level. Now, also, of course, one of the differences is that you can failover multiple databases simultaneously in auto failover groups. Then another difference is the connection string. So for GeoDR, the failover must be initiated manually by the application or the user. After the failover, the new primary has a different connection endpoint. In the case of auto failover groups, we provide a listener endpoints, a DNS, that basically remain unchanged during failovers. So after the database failover is complete, the DNS record is automatically updated to redirect the endpoints to the new region. So basically the endpoint will be the same. It will just be pointing internally to the new region where the primary is located now. That's also one of the differences. Now, the other thing is for GeoDR, you can have the secondaries in the same or different region. For auto failover groups, it has to be in different region. You can have multiple replicas with GeoDR. We already saw that up to four, but if you do chaining, you can have a limitless number of replicas. In the case of auto failover groups, you can only have just one of the entire group, only one replica in a different region. And of course, as we mentioned, both of them have read scale. That means that you can use as a read-only database for the secondaries. You can use this for reporting, for example. Now, here I have a comparison about how other cloud platforms uh, managed GeoDR. I mean, my intention here is not to compare all the features that AWS has in their database offerings or in Google Cloud. The only thing I'm focusing is, okay, in the case you have Azure SQL or a SQL Server engine, how do other clouds manage geo-replication? Well, in the case, for example, of AWS, you can deploy a SQL Server engine in something called Amazon RDS. Amazon RDS is available on several database instances types like Aurora, PostgreSQL, MySQL, MariaDB, Oracle, and of course SQL Server. Now, currently, creating a read replica in a different AWS region is not supported. So basically, a cross-region read replica for the SQL Server engine, this is not supported currently in AWS. The other thing is, if you set up your own geo replication in Amazon, and then you start having problems with the lag, let's say like the lag between the primary and secondary start increasing, Amazon won't intervene to mitigate this high replica lag between the source database and the replica. Now, in the case of Google Cloud, Google Cloud has something called Cloud SQL for SQL Server. Basically, they are using, again, the SQL Server engine in a managed service. They do not support currently cross-region replication. They do support this now for MySQL and PostgreSQL, but not for SQL Server engine. So basically, GeoDR for SQL Server is something very specific to Azure. It's a solution that you can only have in the Azure cloud. Now, some of the interesting things that we're having, what is new in GeoDR, as you know, we currently have geo-replication for Azure SQL Hyperscale is currently in preview. Hyperscale Service Tier is an Azure SQL database where you can support up to 100 terabytes of database size. And currently we have certain limitations in this preview, but we want Hyperscale to have the same capabilities for GeoDR as other services tiers like general purpose and business critical. And we're also going to be having failover groups support for Hyperscale in the future. Now, another interesting thing is Hyperscale database copy is GA. Actually, yesterday was the GA announcement for this. So basically, now you can, in Hyperscale, you can generate a transactional consistent database copy to either the same or different logical server or region. It works the same way as database copy that we have already supported for other services tiers. And this enables the scenarios where hyperscale database have to be copied for various reasons, such as the development or testing. And of course, if you're doing a cross-region database copy, it's going to take more time than if you're doing a local copy that actually doesn't matter the size of the database, is going to be it's going to be a fast copying into the same region. So now, we have been discussing today different things for high availability and disaster recovery. Here we have a table of the service tiers and what SLAs do we have for high availability options for GeoDR, the RPO and RTO. Of course, in the case of failover groups and geo-replication. If you have, of course, any question and you want to go in detail, in detail, how do we support these RTOs and RPOs in different scenarios and service tiers. Also, we have some resources here to everything we mentioned here, you can find in our documentation even more details, of course, about availability zones, active view replication, failover groups. And also you can take a learning course where you will actually be deploying high availability solutions. So you will learn how to do it. And we already have, of course, the resources of details of the SLAs where we how we support these SLAs.
Great. Yeah, no, thank you, everyone. Yeah, please let us know if you have any questions.
Yeah, feel free to contact us and we'll be happy to, answer more detail, even do a call. So I think that's it from our side. Thank you.
Thank you. Have a good one.